For centuries, the process of making legal agreements has been rooted in outdated manual practices. Contracts were handwritten or typed on machines, depending on the level of formality, and required a series of intermediaries. Lawyers, notaries, and courts were responsible for ensuring both parties fulfilled their obligations. While the system worked adequately for a long time, it was far from perfect. Frauds, mistakes, and human errors were common, creating uncertainty and additional costs for the parties involved. Furthermore, traditional contracts were vulnerable to manipulation and mistakes. A simple typing error or failure in communication could invalidate an entire agreement, leading to massive losses for the parties involved. Even more concerning was the fact that these contracts relied on the good faith of third parties for enforcement, such as lawyers and financial institutions. The reliance on so many intermediaries not only created extra costs, but also increased the possibility of system failures. It was in this climate of uncertainty and failure that the need for a revolution emerged. Traditional contracts had reached a critical point where human trust and reliance on intermediaries were no longer enough to ensure the integrity of transactions. Then the idea emerged to use technology to create contracts that depended on nothing but the programming itself and trust in the code. It was time for a new system more efficient, more secure, more transparent. Ethereum emerged as an innovative proposal to transform the concept of digital contracts. Created by Vitalik Buterin in 2013, Ethereum was not just a digital currency, but a decentralized platform that allowed the creation and execution of smart contracts through its blockchain. Buterin, a Russian-born programmer, had the vision to create a network that was more flexible than Bitcoin, allowing developers to build decentralized applications and self-executing contracts that could function without intermediaries, eliminating the flaws of traditional contracts. The concept of Ethereum was unveiled to the world in 2014 when Buterin published the white paper outlining his vision for the platform. Unlike Bitcoin, which aimed to be a decentralized digital currency, Ethereum was designed to be a versatile platform, enabling the execution of smart contracts and the creation of dApps, decentralized applications. The proposal was revolutionary because it allowed anyone to create and execute contracts without the need for intermediaries or the approval of a central authority. In 2015, the Ethereum network was officially launched, bringing with it the promise of a new era for smart contracts. The first version of the platform allowed developers to test their smart contracts, exploring a new model of decentralization that was more secure, transparent, and efficient than existing solutions. Ethereum was not limited to financial transactions. Its true power lay in the creation of complex contracts and applications that could operate autonomously, without the need for intermediaries. Smart contracts are self-executing programs that operate on a blockchain, where the terms of the contract are written in code. Unlike traditional contracts where enforcement relies on trust and intermediaries, in smart contracts, execution is guaranteed by the code's programming. When predefined conditions are met, the contract is automatically executed without any human intervention. This autonomy eliminates the flaws and uncertainties common in traditional contract systems. The concept of a smart contract can be compared to an automatic agreement machine. Imagine a system that performs actions without human intervention, relying solely on the verification of data. For example, if you make a payment to someone, a smart contract can be set up to automatically release a product when the payment is confirmed. The power of smart contracts lies in transparency. All conditions and terms are visible to anyone with access to the blockchain, ensuring there are no manipulations or surprises. In addition to transparency, security is one of the greatest advantages of smart contracts. Since contracts are stored and executed on the blockchain, once they are created, they are immutable. This means they cannot be altered or manipulated after being established. This ensures the integrity of agreements, as any attempt to modify them will be visible to everyone on the network. Ethereum's decentralized nature also prevents any single entity from altering or censoring the contract. Decentralization is one of the fundamental pillars that differentiates Ethereum from traditional systems. Instead of relying on a single authority, such as a bank, government, or court, to validate and execute contracts, Ethereum distributes this responsibility across thousands of nodes, computers around the world. This means there is no single point of failure or centralized control, making the network more resistant to censorship and less vulnerable to attacks. Decentralization also ensures that all transactions and contracts are transparent and accessible to anyone on the network. Decentralization also removes the need for intermediaries, such as lawyers and banks who traditionally ensure the enforcement of a contract. With Ethereum, trust is no longer placed in a third party, but in the code itself. This eliminates unnecessary costs and minimizes the chances of human errors, manipulation, or corruption. The fact that anyone with access to the network can create and execute smart contracts is a true revolution in the way transactions and agreements are made, as it makes the process accessible to anyone, anywhere, without the need for a central authority. This autonomy offered by decentralization also has a profound impact on security. In a centralized system, like a bank, any vulnerability in the infrastructure can compromise the entire process, as seen in countless hacks of banking and government systems. However, on Ethereum, there is no single vulnerability that can be exploited by a centralized attack, making the system much more robust and secure. Decentralization is undoubtedly one of Ethereum's greatest advantages, and its ability to eliminate the risks of failures or manipulations in traditional systems represents a true revolution in the concept of digital contracts. The programming language Solidity is the primary tool used to create smart contracts on the Ethereum blockchain. Specifically designed for this purpose, it allows developers to write self-executing contracts with security, efficiency, and flexibility. Solidity is a high-level language that resembles JavaScript and other popular programming languages, making it relatively easy to learn for developers with programming experience. Its design was aimed at ensuring that smart contracts are secure, robust, and above all, efficient. One of the key advantages of Solidity is its ability to directly interact with the Ethereum blockchain, enabling smart contracts to be executed autonomously and securely. Each line of code written in Solidity is converted into bytecode that is stored on the blockchain, and once deployed, the contract cannot be altered, ensuring integrity and trust. This allows developers to create decentralized applications, DApps, that can run completely autonomously, without the need for servers or intermediaries. The use of Solidity is not limited to simple contracts. Developers can create extremely complex smart contracts with specific rules and conditions that cater to different needs. From decentralized financial systems, DeFi, to non-fungible tokens, NFTs, Solidity enables the creation of a multitude of applications that operate autonomously and decentralize without the need for external oversight. This has opened the doors to a new digital ecosystem where trust is guaranteed by the code, not by authorities or intermediaries. The arrival of Ethereum and smart contracts transformed many industries, opening doors to innovations that once seemed impossible. In the financial sector, the creation of decentralized lending, exchange, and insurance systems eliminated need for traditional intermediaries such as banks and brokers. The concept of decentralized finance, DeFi, gained enormous popularity, enabling anyone, anywhere in the world to access financial services without the need for a centralized institution. In just a few years, Ethereum became the backbone of a new global financial ecosystem. Smart contracts also brought a revolution to the digital art market, especially with non-fungible tokens, NFTs. Before the popularization of NFTs, the digital art market was often hard to navigate, and artists struggled to authenticate and monetize their work. With NFTs, smart contracts enable digital artworks to be registered, authenticated, and bought, or sold in a transparent, immutable, and secure manner. This allowed artists from all over the world to connect directly with collectors and fans without the need for intermediaries like galleries or auction houses. In addition to the financial sector and digital art, the implementation of smart contracts is also impacting industries like real estate, supply chains, and healthcare. In the real estate sector, for example, smart contracts enable real estate transactions to be completed quickly, securely, and without the need for intermediaries like notaries and real estate agents. In supply chains, smart contracts are being used to ensure the traceability of products from origin to the final consumer, increasing transparency and efficiency. In healthcare, smart contracts are helping to create decentralized and secure medical records, as well as enabling more efficient management of health insurance. Since its creation, Ethereum has become a fertile ground for innovation, especially for startups and companies seeking to create decentralized solutions. Ethereum enabled the creation of initial coin offerings, ICOs, a new way to fund blockchain projects. Instead of relying on banks or traditional investors, entrepreneurs could raise funds directly from users and investors without intermediaries. This democratic approach allowed many innovative ideas to become reality, creating an ecosystem of startups focused on developing technological and decentralized solutions. Ethereum not only made it possible for startups to raise funds directly, but it also created a platform for the development of new decentralized applications, DApps. These applications operate without the need for traditional servers or intermediaries, using smart contracts to ensure their execution. As a result, new solutions emerge for various sectors, such as the creation of decentralized marketplaces, games, social networks, and voting systems. Ethereum gave these startups the ability to create disruptive business models that were unthinkable with traditional systems. Over the years, Ethereum has also established itself as a reliable platform for large companies and corporations seeking to integrate blockchain solutions into their business models. Companies like Microsoft, IBM, and JP Morgan began exploring the use of Ethereum to create tracking systems, automated contracts, and decentralized financial solutions. Ethereum allowed these large corporations to leverage blockchain technology in a secure manner without needing to build their own networks from scratch, which accelerated the large-scale adoption of decentralized technologies. As Ethereum grew in popularity and usage, significant challenges related to scalability emerged. With the increase in transactions on the network, confirmation times and transaction fees rose dramatically, creating difficulties for users and developers. The original Ethereum, based on the proof-of-work (POW) consensus mechanism, was not prepared to handle such a large volume of transactions, leading to congestion and high costs. This sparked the urgent need for solutions to improve the network's performance without compromising security or decentralization. In response to the scalability issue, the Ethereum team began developing a series of solutions, the most significant being Ethereum 2.0. The transition from proof-of-work (POW) to proof-of-stake (POS) promises to solve many of the scalability problems, allowing the network to process a significantly larger number of transactions without compromising security. Additionally, Ethereum 2.0 introduces solutions like sharding, which divides the network into smaller shards, enabling different parts of the network to process transactions simultaneously, further reducing costs and increasing platform efficiency. The implementation of these scalability solutions is not only aimed at improving the network's capacity, but also ensuring that Ethereum remains a viable and efficient platform as global adoption grows. Ethereum 2.0 is designed to be more eco-friendly, consuming less energy compared to POW, reflecting the growing focus on sustainability within the blockchain space. Furthermore, by improving scalability, Ethereum also opens the door for new innovations, enabling more decentralized applications and smart contracts to be deployed without worrying about network limitations. While Ethereum brought numerous benefits, it also faced significant challenges regarding security. The fact that smart contracts execute autonomously means that errors in the code or design flaws can result in serious consequences, including financial losses. One of the most notorious incidents was the hack of the Decentralized Autonomous Organization in 2016, which exploited a vulnerability in the smart contract code and led to the theft of millions of dollars. This event was a turning point for Ethereum, highlighting the need for more robust security measures and the importance of rigorous audits. After the DL hack, the Ethereum community came together to implement significant changes to the protocol. The incident led to the hard fork of Ethereum, which split the original blockchain and created the current Ethereum, with the goal of reversing the compromised transactions and returning the stolen funds. Additionally, the community began adopting more rigorous practices to ensure the security of smart contracts, such as more frequent audits, stricter security tests, and the introduction of tools to detect vulnerabilities before contracts were deployed to the main network. These measures helped increase trust in the platform and ensured that security flaws would not jeopardize the ecosystem. Over time, Ethereum continued to improve its security practices by introducing solutions like Ethereum Improvement Proposals, EIPs, and the use of smart contracts audited by external security firms. These improvements allowed the network to become increasingly secure and reliable. The growing adoption of Ethereum by large companies, along with its transparency and decentralization, contributed to strengthening the platform. While risks will always exist in the digital space, Ethereum demonstrated its ability to learn from past failures and implement solutions that make its network more resilient to external threats. The future of Ethereum and smart contracts is filled with exciting possibilities. As more sectors adopt decentralized solutions, Ethereum will continue to evolve, offering a more scalable, secure, and efficient platform. With the implementation of Ethereum 2.0 and its scalability improvements, Ethereum is positioned to support wider mass adoption, enabling more users and developers to benefit from its capabilities. Furthermore, new technologies like sharding and rollups promise to further improve the network's performance, enabling it to process thousands of transactions per second without compromising its security or decentralization. In addition to technical improvements, Ethereum will also continue to serve as the foundation for the creation of new types of smart contracts, increasingly adapted to various industries. For example, smart contracts could be used for new forms of decentralized governance, where decisions are made automatically based on programmed rules without the need for a central authority. This could revolutionize how businesses and even governments operate, making processes more transparent, faster, and more efficient. The decentralization of decision-making processes is one of the most powerful innovations that smart contracts could bring to the future. The impact of smart contracts in Ethereum is not limited to what has been achieved so far. With the continuous advancement of blockchain technology and Ethereum's ongoing innovation, it is expected that more people and businesses will adopt these decentralized solutions in the coming years. Ethereum is building a new global economic infrastructure where trust is guaranteed by code, not intermediaries. As more sectors join this digital revolution, Ethereum will continue to be the key to unlocking a more fair, transparent, and decentralized future.